Imagine the irresistible appeal of warm, gooey cookies, crunchy candies, rich cakes, or ice cream stacked in a crisp waffle cone. The moment you picture them, your mouth might start to water and your body begins to crave something sweet. But why does this happen? What makes sugary foods so hard to resist? The answer lies in how sugar affects the brain. Sugar is a general term that refers to a group of molecules known as carbohydrates, which are found in many foods and drinks. When you read ingredient labels, you'll find various types of sugar listed: glucose, fructose, sucrose, maltose, lactose, dextrose, and starch. Others, like high fructose corn syrup, honey, fruit juice, and raw sugar, also belong to this family. Sugar isn't only in obvious treats like candy and desserts, it's hidden in everyday items such as tomato sauce, yogurt, granola bars, and flavored drinks. Because it's so widespread, understanding how sugar interacts with the brain helps explain why it's so tempting. When sugar first hits your tongue, it activates sweet taste receptors located on the taste buds. These receptors send signals to the brainstem, which then forwards them to several parts of the forebrain, including the cerebral cortex. Different areas of this cortex are responsible for processing specific tastes: bitter, salty, sour, umami, and sweet. Once the brain recognizes the sweet taste, it triggers the brain's reward system, a network of electrical and chemical pathways that governs feelings of pleasure and motivation. This system exists to answer a subconscious question: should I do that again? The pleasant sensation you feel after eating something sweet like your grandmother's chocolate cake is the brain's way of encouraging that behavior. This reward system isn't exclusive to food. It also responds to experiences like social interaction, sexual activity, and even drug use. When activated moderately, it reinforces behaviors that are beneficial for survival and well-being. However, overstimulation of this system can lead to negative outcomes such as cravings, loss of control, and increased tolerance, common traits of addiction. After you swallow that bite of something sweet, it travels through the digestive system to the stomach and gut, where more sugar receptors await. Though these aren't taste buds, they still play an important role by sending messages to the brain about how much food has been consumed. They help regulate the release of insulin, a hormone responsible for managing blood sugar levels, and inform the body when it's full. At the core of the brain's reward system is a neurotransmitter called dopamine. Dopamine is a chemical messenger that creates feelings of pleasure and reinforcement. The brain contains clusters of dopamine receptors, particularly in regions associated with reward and motivation. When these areas are flooded with dopamine, they produce the sense of satisfaction that follows enjoyable experiences. Drugs such as nicotine, alcohol, and heroin dramatically increase dopamine levels, creating powerful highs that can lead to addiction. Sugar, while less potent, stimulates dopamine release in a similar way, which explains why it can be so enticing and habit-forming. Unlike sugar, most other foods do not trigger dopamine release in the same way. Vegetables, such as broccoli or spinach, for instance, have little to no effect on dopamine levels, which is one reason they rarely inspire the same cravings. However, when you eat a nutritious, balanced meal, your brain still releases dopamine as part of the reward for nourishment. Over time, if you eat the same meal repeatedly, dopamine levels gradually decline with each serving. This happens because the brain naturally loses interest in familiar flavors, an adaptation that encourages dietary variety. By seeking out new foods, humans historically increased their chances of obtaining a full range of nutrients while avoiding spoiled or toxic substances. Sugar disrupts this natural balance. When you eat a sugary food, the brain reacts as it would to a rewarding meal. But unlike with most foods, dopamine levels don't return to normal even after repeated exposure. Instead, they continue to spike, reinforcing the desire for more sugar. This constant stimulation of the reward system mirrors the mechanism behind addiction. leading to persistent cravings and difficulty moderating intake. Essentially, sugar tricks the brain into wanting more, regardless of how much the body actually needs. Different forms of sugar may vary in sweetness or how quickly they enter the bloodstream, but they all affect the brain in similar ways. Each sugary bite triggers a chain reaction of signals that results in pleasure and reinforcement. While the occasional sweet treat is harmless, consistent overconsumption can condition the brain to crave sugar frequently, leading to unhealthy eating habits and potential long-term effects such as obesity, diabetes, and heart disease. Despite sugar's addictive potential, moderation remains key. The brain's reward system evolved to encourage survival behaviors, not to punish indulgence. A slice of cake at a celebration or a scoop of ice cream on a hot day isn't dangerous. It becomes a problem only when such habits turn into constant consumption. Understanding how sugar affects the brain allows us to make more mindful choices about what we eat. By balancing sweetness with nutritious foods and variety, we can satisfy cravings without letting them control us.